In the mining industry, large industrial mills use steel balls to crush mineral ore and reduce it into increasingly finer particles. These balls operate under extremely demanding conditions, constantly subjected to impacts, wear, and heavy loads during the grinding process. This raises an important question. What happens when one of these balls fails, wears out too quickly, or even fractures? To answer that question, it is necessary to analyze the material in detail. In this laboratory, we perform different metallurgical analyses that allow us to understand how the grinding ball was manufactured and how it behaved during operation. The first step is to cut a section of the grinding ball. For this purpose, we use a metallurgical cutting machine that cuts the material while using coolant to prevent heat from altering the steel's internal structure. This allows us to obtain a sample with a suitable size for laboratory analysis. Once the sample is obtained, it is mounted in resin, forming what is known as a metallurgical mount, or briquette. This mounting process makes the sample easier to handle and ensures that the surface to be analyzed is properly positioned for the next stages. The sample then goes through a grinding and polishing process, where the scratches generated during cutting are progressively removed using increasingly finer abrasives. The goal is to obtain a completely smooth and highly polished surface, almost like a mirror, which is essential for clearly observing the internal structure of the material. Once the surface is perfectly polished, a chemical reagent is applied in a process known as chemical etching. This reagent reveals the steel's microstructure by highlighting the different constituents of the material and making its internal structure visible. Finally, the sample is analyzed using metallurgical microscopy, allowing us to observe the material's microstructure and evaluate important characteristics such as grain size, the phases present, and possible defects in the steel. Through this type of analysis, it is possible to understand how the material was manufactured and detect potential issues related to heat treatment, chemical composition, or the manufacturing process, providing key information to explain the behavior of grinding balls during their operation in the mining industry.